Module 4, Energy Resources. Content Standard, the various sources of energy. Most essential learning competencies are: describe how fossil fuels are formed, explain how heat from inside the earth is tapped as a source of energy for human use. Learning objectives, you're going to describe how fossil fuels are formed, explain how heat from inside the earth is tapped as a source of energy for human use, explain how energy is harnessed from flowing water, and create individual models explaining how fossil fuels are formed and how geothermal and hydroelectric energy are harnessed for human use. Energy. It is the capacity for doing work, the process of transfer from one body to another. It is also known as a power derived from the utilization of physical or chemical resources, especially to provide light and heat or to work machines. And there are different forms of energy. We have thermal energy. It is the energy contained with a system that is responsible for its temperature, and heat is the flow of thermal energy. It also includes thermodynamics that deals with how heat is transferred between different systems and how work is done in the process, which is also known as the first law of thermodynamics. Next, we have chemical energy. This may be released during a chemical reaction, often in the form of heat. Such reactions are called exothermic. Then we have electrical energy. It is the form of energy resulting from the flow of electric charges. The force is electrical attraction or repulsion between charged particles. Nuclear energy. It comes from splitting atoms in a reactor to heat water into steam, turn a turbine, and generate electricity. Next, we have sound energy. It is the movement of energy through a substance wherein it is produced when a force causes an object or substance to vibrate. Light energy is a form of electromagnetic radiation wherein it consists of photons which are produced when an object's atoms heat up. And then we have mechanical energy. This energy is possessed by an object due to its motion or due to its position. Mechanical energy can be either kinetic energy or energy of motion, or potential energy, which is a stored energy of position. When we say potential energy, it is a stored energy that depends upon the relative position of various parts of a system. While kinetic energy, it's a form of energy that an object or a particle has by a reason of its motion. Okay, so we have energy resources. It is referred for all forms of fuels used in the modern world, either for heating, generation of electrical energy, or for other forms of energy conversion processes. Then next there are two types of energy resources. We have renewable resources and non-renewable resources. When we say renewable sources of energy, this is our elements that can be replenished over time through a natural processes. This means this energy that is sustainable, something that can't run out. And there are most popular renewable energy sources, which include solar energy, wind energy, hydro energy, geothermal energy, and biomass energy. Next, we have non-renewable resources, which the source of energy that will eventually run out. This is a natural resources that cannot be readily replaced by natural means at a quick enough pace to keep up with consumption. And there are major types of non-renewable resources. We have coal, oil, and natural gas. Fossil fuels are made from decomposing plants and animals. These fuels are found in the Earth's crust and contain carbon and hydrogen, which can be burned for energy. Coal, oil, and natural gas are examples of fossil fuels. Fossil fuel is a general term for buried combustible geologic deposits of organic materials formed from decayed plants and animals that have been converted to crude oil, coal, natural gas, or heavy oils by exposure to heat and pressure in the Earth's crust over hundreds of millions of years. The burning of fossil fuels by humans is the largest source of emission of carbon dioxide, which is one of the greenhouse gases that allows radiative forcing and contributes to global warming. Then we have major types of fossil fuels. We have coal, a material usually found in sedimentary rock deposits, where rock and dead plant and animal matter are piled up in layers. More than 50% of a piece of coal's weight must be from fossilized plants. How coal is formed? Coal is formed over millions of years by decay of plant vegetation when layers are compacted and heated over tiny deposits turned into coal. Coal is usually extracted in mines. Many developing countries depend on coal for energy because they cannot afford oil or natural gas. China and India are major users of coal energy. Oil. It is originally found as a solid material between layers of sedimentary rock like shale. This material is heated in order to produce the peak oil that can be used to make gasoline. How oil is formed? After millions of years, the deposits end up in rock and sediments where oil is trapped in small spaces, and it can be extracted by large drilling platforms. In other references, oil is a liquid fossil fuel that is formed from the remains of marine or microorganisms on the seafloor. Next, natural gas. It is a gaseous fossil fuel which is usually found in packets above oil deposits. Or it is a gaseous fossil fuel that is versatile, abundant, and relatively clean compared to coal and oil. How natural gases form? It can also be found in sedimentary rock layers that don't contain oil, and it is primarily made up of methane. Actually, natural gas has now overtaken coal in developed countries. However, people are afraid that like oil, natural gas supplies will run out. How heat from inside the earth is tapped as a source of energy for human use. Geothermal energy. It is the thermal energy generated and stored in the earth. It originates from the original formation of the planet and from radioactive decay of materials. This heat from the Earth's interior is a source of energy called geothermal energy. How is geothermal energy generated? It is produced by the heat of Earth's molten interior. This energy is harnessed to generate electricity when water is injected deep underground and returns as steam to drive a turbine on an electric power generator. Base from the illustration of geothermal energy processes, to harness the energy, deep holes are drilled into the earth, much like when drilling for oil, until a significant geothermal hot spot is found. When the heat source has been discovered, a pipe is attached deep down inside the hole, which allows hot steam from deep within the earth's crust to rise up to the surface. The pressurized steam is then channeled into a turbine, which begins to turn under the large force of the steam. This turbine is linked to the generator, and so the generator also begins to turn, generating electricity. We then pump cold water down a new pipe, which is heated by the earth and then sent back the first pipe to repeat the process. There is a natural source of power found below the surface of the earth that has been around for centuries. Underground, far below us, there are pools of water heated by magma or molten rocks. These pools of water make up our geothermal reservoir, harnessing the power of the Earth's temperatures to power, heat, or cool our homes and businesses in the essence of geothermal power. Geothermal energy is generated in two ways. We have geothermal plants and geothermal heat pumps. They differ on the depth of heat source to produce energy. Geothermal power plants are hydrothermal resources that come from either dry steam wells or from hot water wells. These are the main types of geothermal energy plants that generate power in slightly different ways. Geothermal heat pump, it is a ground source heat pump which is a central heating or cooling system that transfers heat to or from the ground. So based from the illustration, we have binary cycle power plant. In this binary cycle plants, the main difference is that the water or steam from the below the earth never comes in direct contact with the turbines. Instead, water from geothermal reservoir is pumped through a heat exchanger where it heats a second liquid. The second liquid is heated into steam, which powers the turbines that drives a generator. The second liquid is recycled to the turbine and back into the heat exchanger where it can be used again. So there are two main types of geothermal energy plants that generate power. So we have dry steam power plant and flash steam power plant. When we say dry steam plants are the most common types of geothermal power plants. They work by piping hot steam from underground reservoir directly into turbines from geothermal reservoir, which power the generators to provide electricity. After powering the turbines, the steam condenses into water and it is piped back into the earth via the injection well. While the flash steam power plant, they are differ from dry steam because they pump hot water rather than steam directly to the surface. Geothermal heat pump. Powering your home with geothermal heat pump allows you to harness the temperatures below the surface of the earth to heat or cool a structure. Even though the temperatures above ground fluctuate during the seasons, throughout the years, the temperature below the surface remains consistent between 50 degrees Fahrenheit to 60 degrees Fahrenheit year-round. And there are four types of pumps. We have three closed loop systems and open loop system, which is depend on the type of soil, climate conditions, and land availability. We have here the open loop system. In open loop system, the water is taken directly from a water source and into the heat pump, where it then can either be recycled back into the same source or pumped into another water source without polluting. The only difference with the water going in and out is a slight change in temperature. Although this can be cheaper, they also require a steady flow of water capable of powering your home. So we have the three closed loop systems. In closed loop systems, a water anti-freeze mixture circulates through a loop of pipes underground or beneath a body of water into a building. Then the electric compressors and heat exchangers transfer the heat through ducts in the building. So we have the closed loop horizontal systems are the most cost-effective for residential areas, and we have the closed loop vertical systems, which are more often used for larger commercial buildings, which can be sometimes go down 400 feet deep, and we have closed loops constructed under or in a pond or lake are usually the cheapest.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon State Line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing
energy demands.
In the Philippines, the Bacman Geothermal Power Plant in the Bicol region are used to generate electricity in Tiwi Albay, Sidapawan, North Cotabato, Calacan, Laguna, Tongonan, Leyte, and Bacon, Sorsogon. Can energy be generated through water? When water flows or falls, energy can be generated. The energy from moving water can be used to create electricity in several different ways. How energy is harnessed from flowing water? Hydroelectric power, it is also called hydropower, that harnesses the power of water in motion, such as water flowing over a waterfall to generate electricity. A hydroelectric power plant consists of a high dam that is built across a large river to create a reservoir and a station where the process of energy conversion to electricity takes place. How energy generated in hydroelectric power plant? The electricity produced from generators driven by turbines that convert the potential energy of falling or fast-flowing water into mechanical energy. The water falls through a dam into the hydropower plant and turns a large wheel called turbine. The turbine converts the energy of falling water into mechanical energy to drive the generator. It turns a shaft which rotates a number of magnets in the generator. When the magnets pass copper coils, a magnetic field is created which aids the production of electricity. Step-up transformers will then increase the voltage of the electricity to levels needed for the journey to communities. After this process has taken place, electricity is transferred to the communities through transmission lines and the water is released back into the lakes, rivers, or streams. This is entirely not harmful because no pollutants are added to the water while it flows through the hydropower plant. Based from the illustration, the bigger the height difference between the upstream and downstream water level, the greater the amount of electricity generated.
Water covers 71% of the Earth's surface and is vital to our daily lives. It can also be a clean, renewable, reliable source of electricity. Hydroelectric energy comes from capturing the force of moving water that's in our Earth's rivers and oceans. We do this by using the movement of the water to spin hydraulic turbines. That generates kinetic energy, which is converted to electricity through a generator, and then sent to the power grid. Most hydropower is generated from dams built on rivers and streams, often where there's a big drop in elevation, so gravity can help us out. Dams block the water's natural flow and force it through a large pipe with the turbine and generator, before releasing it back into the stream on the other side of the dam. Today, we know that dams, most of which were built before the 1960s here in the US, can disrupt river ecosystems. There haven't been many new hydro plants built in the US in a few decades, but some existing dams are beginning to be tapped for their electricity generating potential, and existing hydro facilities are being upgraded to be less harmful to plants, fish, and wildlife. This helps us get the electricity we need while protecting the natural environment around us. Now that's a win-win.
We have the importance of energy resources. We have geothermal energy and hydroelectric energy. So sa geothermal energy, we have the advantages and disadvantages. Some of the advantages are renewable energy resource. It means overall, geothermal energy is sustainable resource. Low fuel cost. It means it saves 80% cost over fossil fuels and no fuel is Geothermal energy is very efficient and long-lasting. So it means it is a renewable energy sources, and the governments of various countries are investing hugely in creation of geothermal energy, which on the other hand has created more jobs for the local people. Clean resource, it means the main advantage of using geothermal energy is that it does not create any pollution. Thus, it emits small amounts. It has helped on the reducing of global warming as well as pollution. Some of the disadvantages of geothermal energy, we have here resource risk. If not carefully managed, a borehole can run out of steam and may not be usable for several decades. Dangerous gases and minerals can come out of a borehole, which may be difficult to dispose of. Then, another one, we have difficult to find suitable sites to build geothermal power stations. So it means proper sites for plants are not very common because of this geothermal energy. And number 3, we have supply could change and cannot be transported. And number 4, it creates noise, pollution, and releases noxious smells. Hydroelectric energy, there is certain advantages and disadvantages. Advantages, number 1, renewable energy resource, same as it is a sustainable sources of energy. No greenhouse gases produced. It means no other dangerous gases are produced, so there's no damage in this kind of the environment. Low power cost, meaning there's economic benefits. No fuel cost, low labor, and the low power cost, there's no fuel is needed, therefore the price of hydroelectricity will not change if the price of fuel increases. And we have clean fuel source. Clean fuel source, so it means it uses, of course, it's fueled by water, so it means it's a clean fuel source. Some of the disadvantages of hydroelectric energy. So we have here expensive to build dams. So it means hydroelectric plants are very expensive to build and must be built to a very high standard. And then we have slow down electricity production. So it means when water is not available, the hydropower plants can't produce electricity. Can only be used in mountainous areas, and people living near dams may be flooded and move out. So it means the creation of dams can also create flooding of land, which means natural environment and the natural habitat of animals and even people may be destroyed. So geothermal and hydroelectric are renewable sources of energies and produce clean fuel sources. Geothermal energy is heat stored deep inside the earth or occasionally in hot springs, while hydropower is fueled by water. Therefore, it is sustainable fuel source. Next, you're going to have a group activity. Make an individual models of the following. How does the energy harness for human use? Geothermal energy, hydroelectric energy, and how fossil fuels are formed. And we have here guide questions. How geothermal and hydroelectric power works. Why is it important to manage our natural resources, and how natural resources play an important role in our daily life. And we have here an activity sheet 1.2, individual activity. We have geothermal